What's up, guys? All right, we are at class number 8. This one should go pretty quick as well. We don't have a lot more to go in this particular chapter we're on. So let's just kind of jump right into it. All right, so we're going to first talk about a concept called breaks and what a break is. So when we went over switch statements, you saw that whenever you had a case statement for a particular expression, you were able to say a bunch of lines of code, and then you could use a break statement. But if you didn't use a break statement, it would actually fall through to the next logic chunk, even though you clearly had a different case labeled. And the reason for that is because break is the only way to exit a case statement out of a switch. And similarly, if you want to early exit out of any kind of looping control mechanism, you have to use break. So there are a bunch of different uses for that, and we're just going to kind of jump in and show you some examples. But before we do that, I'm going to go over to the blackboard and do my standard add a bunch of stuff. Okay. So the first one I'm going to show you is how we can break out of an if check. Okay. So if condition, right? Then you could say like do some stuff, and then you could do break, right? And now, by itself, that seems kind of superfluous. Like, okay, you did some stuff. Why would we want to break? Because it's already going to exit here. Okay, but I'm going to add to this, right? So I'm going to do while some condition, right? Let's go ahead and indent this stuff, right? Nope, I want to do that. Okay, so effectively, so follow with me here for a second. I'll explain this in a second. Okay, so what we have is a while loop, okay? And in this while loop, we have a condition. And let's assume that it almost always fails to trigger this in here. So it's going to execute the code down here. It's going to go back up again. It's going to do it again, do it again, do it again, do it again. So while this has an outer condition, the if check internally has its own condition. And when that condition is fulfilled, we can essentially break out of that if check. But it's not just the if check, right? It breaks out of the while loop. So it actually exits the if, and it breaks out of this because it is mapped directly to the while loop. Okay? So that's something to keep in mind. The break isn't intrinsically tied to the if check. It is tied to the loop itself. So switch statements and loops. Okay? Cool. So with that said, I'm going to go over to this little demo we've got here. Okay? All right, so we're going to use a break to exit a loop. All right? Okay. So what I'm going to do is I'm going to have a for loop that's going to start with an integer I, right? Okay. And I'm going to control it by some other value called num. So let's go ahead and let's make an integer called num out here, right? And then let's go ahead and increment that up. All right. Okay, so I'm going to do some logic, some simple arithmetic here. And once I gets greater than num, it should exit out because I'm going to put a condition in there, right? But see, let's just assign 100 to that. So our max value is going to be 100, and I is going to start at 0. So we know that I is going to execute this loop about 100 times. actually exactly 100 times, right? And then the 101th time, when it gets to 100, it's going to fail this check. But we want it to exit sooner so that you can show how a break actually works, okay? So what I'm going to do is I'm going to take I times I, and there's actually no reason why I'm choosing to do this other than I times I will always be greater than I, which means this if check will succeed faster than the for loop will fail, okay? So I'm going to say when I times I is greater than or equal to num, right, then I'm going to go ahead and break, right? And this is going to terminate the loop if I times I is greater than or equal to 100, okay? Right? So let's go ahead and print out the for loop every single time. So we're going to do I, and then, cool. We'll just do that. So we'll just like print the number, space, print the number, space, print the number, space, etc., etc. I'm so sorry, guys. I'm so sorry. I just got a notification that I forgot to hit the screen display. So, let's go over this one more time. It's really quick. So you've been listening, but you couldn't see. So here, let me break it down. Here's the while loop that I put together on the blackboard. So while you have a condition, then you basically do some code every time. This will fail, right? And then when this condition hits, we're going to do some stuff, and then we're going to break out, which means this will no longer execute because the while loop has exited. Cool. All right, we're on the same page. Awesome. Okay, so going back to the break demo. So again, we're creating a number, just an int. We're setting it to 100, and we're iterating our for loop from I up to num. But we want our internal if check, just as we showed in the Blackboard example, we want it to fail faster than the for loop will fail. Okay? So we're going to take the iterator here, I, and we're going to multiply it by itself, and it should be greater than or equal to num far faster than the for loop will get to its fail condition, which is this. Okay, so this will be reached before this is reached, okay? So this statement here, we're just going to print out I each time the for loop runs, okay? Awesome. And then we're going to go ahead and print out a sanity check here, just saying that the loop is complete, okay? All right, cool. So if this doesn't work as I suggested, then we should see 0, 1, 2, 3, all the way up to 99, and then it should say loop complete. If I'm correct, then as soon as I hits 10, 10 times 10 is greater than or equal to 100, we should hit this break. So I should only see 0 through 9 here, okay? So let's go ahead and go into class 8. All right, and let's compile the break demo, and let's run it. So remember, what is this? Of course. Code all day? I forget how to code. All right, try that one more time. Come on. Cool. All right, let's run that. And there we have it, 0 through 9, okay? So we've successfully shown that as soon as this I hits 10, the for loop would have kept going, but this got triggered. We hit the break statement, and it exited the loop down to here, okay? So break doesn't have to do specifically with the if check. It will break out and not do some code. So like if I were to say, I don't think this is going to compile. I think it's going to tell me this is unreachable code, but let's find out. Right? Yep, unreachable statement. So it tells me that this can never actually get hit, right? Cool. All right. Awesome. Okay, cool. So that's the first break demo, right? So now we're going to show you a similar demo. that basically has an infinite loop. Okay? So, 1 second here. Right. So we're going to use input to do that. Okay. So we're going to read input until a cue is received. Okay. So what we're going to do is we're going to use an infinite for loop. So we learned how to do this. Basically has no iterator, no condition, and no increment. Right? So there's our infinite loop. Okay. We're going to use the read command. So we're going to have to declare that this function throws the Java IO exception. Okay. We're also going to need to catch the character. Let's call it input. Okay. All right. All right. So what we want to do is we want to get the character. Okay. So system.in.read. Remember, we have to cast it to a character because it comes out of this as an integer. So we're going to grab the character, and we're going to say, if the input equals a cue, right, then we're going to break. Okay? But let's put outside of the for loop, a statement here that says you press Q, so you know that you exited the for loop, because you're not actually going to exit the for loop. It's just going to keep asking you for input until you enter a Q. Okay? So let's go ahead and compile that one. Okay? Let's try that. Okay, so we didn't actually we never put anything here. So let's actually put something there. So okay, cool. Let's exit out of that. Okay. Let's compile that again and run it. I want some kind of feedback, right? Cool. Enter a key. W. Okay, remember we got that double buffer thing. I'm not going to bother with it, but so enter key, infinite. I could just go forever and ever and ever and ever, right? Forever. Now I'm going to hit a Q. You press Q. Okay, cool. So as soon as you hit Q, it exits. So this thing will go forever until you enter a Q. Okay, so now you can see how you can use a break statement for controlling input to the keyboard, or expectations of the input to the keyboard. Okay, and that can be useful later down the road. Okay, cool. All right. Now, let's talk about a nested loop. Okay, that's a loop within a loop. Okay, and we've done stuff like this already, right? We've done nested loops, nested if statements, but we haven't used the break keyword to exit out of those nested loops. So let's go ahead and show an example of that. Okay. So as you can see, I'm just sort of tying all these concepts together. So I'm taking the concept of a break, and I'm tying it into all these different mechanisms that you've already kind of learned already. All right. So let's create an outer for loop. All right. And this one, I'm just going to say it starts at 0, and it goes to 3, and then it exits. All right. Okay. Okay, cool. So I'm also going to have an inner loop, but I'm going to drive that with a variable t. So I'm going to set that t equals 0, right? And I'm going to say while t is less than 100. So I'm going to have that one loop for about 100 times, right? And I want to print it out each time. So let's just start to fill in the blanks here. So follow with me. So I'm going to print out what t is. That's not at all what I meant. Okay, cool. We want to increment t. So we're printing out what t is. We also want to print out the outer loop variable, right? So let's go ahead and do that. So outer loop count. Okay. And then okay, cool. So I'm going to assume that will print once per for loop, and so will this, but it will be immediately followed by all the values of t. So this will be my inner loop count, but it doesn't actually print the value for t because it's going to do that 100 times. Okay. Okay. I also want this one to. I want to print a line here, just an empty line, just to kind of divide each iteration of the for loop. And then when I'm done, I want to print that the loop's complete. Okay. The only thing is that this is going to run 99 times, and I don't really want to do that, right? Like that's a lot. That's going to be a lot for your screen. So here's where we're going to add a break statement. So we're going to say if t is equal to 10, right? Then we're going to go ahead and break. So we're going to terminate out of there if t is equal to 10, okay? So what this is effectively going to show you is that we've got a for loop with a while loop in it with this break statement. And the reason I'm showing you this is because this break statement will affect the while loop, but it will not affect the for loop, okay? So what that means is that I'm going to start my first iteration of this as I equals 0, and it's going to say outer loop count is 0, inner loop count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to break. It's going to print a blank line, and then it's going to go back up here, and it's going to do I equals 1, and then it's going to say outer loop count is 1, inner loop count 0 through 9, blank line 2, and then on third time it will do loops complete, so I should see 0. Outer loop count 0, followed by inner loop count 0 through 9, then outer loop 1, followed by inner loop 0 through 9, and similarly, outer loop count 2, inner loop count 0 through 9. So let's go ahead and run that. Okay, let's clear the screen. Let's compile. Come on. One issue here. Okay, sweet. All right. Cool. So you see outer loop count 0, 1, 2, and then the third time it says loop's complete. Cool. All right. Okay. All right. Now, I'm about to teach you something that is generally not recommended in practice, but it is part of the Java language. So I've never actually used it myself. There's a concept in programming called a goto, and it means that if you put a label somewhere, you can basically tell your code to go somewhere at any given time, and you can basically short-circuit the code. And this was very practical back in the early days of programming, before there was the concept of object-oriented programming, where things were design-based. And that, having large-scale objects that worked with other objects was more preferred for organizational reasons. So these concepts still persist, and you should be aware of them, and you should know how they work. I would say that they should, if you're going to use them, you should not rely on them. And if you're planning to use these in any kind of interviewing questions or on the job, be very, 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 very careful. First of all, don't ever do it in an interview. Don't do that. Second, if you're going to do it on the job, make sure you talk it over with somebody on your team, saying something like, this is isolated code. It's not going to affect anything else. I'm not really sure a better way to do this. This is the quickest way for us to get this out the door. Just consider this an emergency tool only, and use at your own risk. Okay. All right. So basically, a label is just something that you can tell your code to go to. Okay. So let's go over to here. Okay. And this is going to be using a break with a label. Okay. All right. Okay, so I'm going to declare my control variable outside of the loop. All right, so I'm going to create for loop. I equals 1. I is less than 4. Okay, and then I plus plus. Okay, so we're going to go from 1 to 3, and then we're going to exit on 4. All right. Now, normally, you'd want to have another for loop or something here, okay? This is where we're going to use our labels. Again, I don't like this. I'm going to say 1. In fact, I'm not even sure this works in my current version of Java, so this is going to be an adventure for us. If this doesn't work, I'll look pretty stupid. 1, 2, 3. And then on the inside of this, let's go ahead and that's not just like that. Cool. So I'm going to print out a new line. So remember that's escape character for new line. So I is okay. Now, so let's get funky. If I equals 1, you know what? We're going to put these on the same line. Remember, we can do this, right? So we're going to say break to 1. If I equals 2, break to 2. If I equals 3, break to 3. Okay? So I'm going to put a log statement here. Okay, that's never reached. Let's copy this out. So, this is going to be after we execute block 3. So we're going to go through this and then print this. After this one, cool. So effectively, what this is going to print, I is going to be 1, so we're going to go through here, go through here, go through here. I is 1. It's going to say I is 1. It's going to break to 1, and it's going to say after block 1. Then it's going to say I is 2, after block 2, after block 1, and then 3. I is 3, after block 3, after block 2, after block 1. Okay. Now let's see if this actually compiles. Okay. There we go. I is 1. We see 1. I is 2. We see 2 and 1. I is 3. 3, 2, 1. So as you can see, you have just seen a way that you can put this arbitrary label with a block of scope here. So all the code within that scope is mapped to that label. And so if you say go to that label, it's going to go do that label, right? So you could just as easily say, let's do this. Like, let's get rid of the block for 3, right? And we're going to say, so we're going to say I short-circuited the for loop, right? And so we're not going to use this or this. And so actually, instead of that, let's do what I like to do this. Just comment out the code that you don't need. So now in block 2, it maps to everything here because this doesn't exist anymore, okay? So as soon as we get to loop 3, we're gonna jump out of the loop, okay? So let's try that. Come on. Oh, huh. I guess the control statement has to be up here. Well, that's not gonna work so well. All right, so this is gonna end up in an infinite loop. So again, undefined label 3. Ah, because it doesn't exist in the scope. It has to be within the parent-child structure of this. So, like, I could do that. Maybe? Huh. Okay. Well, in any case, this is why you don't use these. At least I would never use it. And nobody's going to be happy with you using that on the job anyway. So just be aware of its existence. And that's one of the reasons why you don't want to use that mechanism. All right. Cool. Let's see. Alright, so I'm going to do a couple more label examples. Just to talk about some additional things here. Okay. So we're going to go ahead and put this up here, top level. Okay. And we're going to go ahead and create a loop control variable. We're going to go 10 times. That's not what I meant. Okay. Let's do the same thing. Let's do that internally. You know, but we're going to do this like 3 layers deep, okay? Alright, so we get down to this inner loop. Alright, I'm going to print the value of k. Alright. Now, if k equals 5, I want to break out of this, but I want to go to done. Right, so I'm going to go all the way up here. Okay. Alright. So this won't execute, right? Because as soon as we break out of here, we're going to go to done. But just for argument's sake, I'm going to do the same thing here because this also won't execute. But this should, right? That's not a file. That's that. Copy and pasted a bunch of errors. Copy pasting is bad. I loop. Okay, cool. All right. So what are we gonna do here? We go into I, go into J, go into K. Once K breaks, we're gonna go up here. I suspect that this is just going to print this over and over, and it's going to be an infinite loop. But, maybe not. Huh. Okay. So printed 0, 1, 2, 3, 4, 5. It went to done. Ah, okay. So effectively what it did was it went up here, but it skipped this and went to the next line of execution because it was in the middle of this line and then skipped this line. Okay? So when done tags this code block, what happens is it actually essentially acts as a massive break to break out of all 3 of these 4 loops. That can be useful. I won't say it's impossible to use that in production code, but I still wouldn't recommend it. Again, use at your own risk. Okay, cool. Actually, I'm going to copy paste this. Ignore me for a second. This was supposed to go in here. That was actually for this particular example. Okay. Right. This is the one that we're... So let's copy this comment here. Okay. So now I want to show... you that label placement matters. Okay. Awesome. Okay. So I'm going to make two integers, set them equal to 0. Okay. And so I'm going to put a label here called stop. Okay. And I'm going to associate it with this block of code. Okay, so it's basically going to start with x equals 0, x is less than 5, x plus plus, so standard for loop. And we're going to fill in the details in a second here. I'm going to make another statement, okay? But what I want to do here is I'm going to start the for loop here, okay? So, you sort of see what I'm doing here. One is putting the label before this code. The next one is putting it after the for declaration within the body. All right, it's actually inside the body, and this will become important in a second. You'll see. So, we're gonna go ahead and we're gonna do another, y is less than 5. Okay. We're going to put that same for loop down here. Okay. All right. Now, up here in this for loop, we're going to say, system out. And we're going to print the values of x and y. Okay. And I want to do the exact same thing down here. Okay. Also, I want to exit the loop when y equals 2. And I want to break up to stop 1. Okay. In this case, I want to do the same exact thing down here, except I want to break to stop 2. Okay. So to split these up, I'm just going to print a blank line. Okay? So what's going to happen here is I'm going to run the for loop. It's going to run 0. It's going to say, okay, x is 0. Then I'm going to go ahead and do the inner loop. Y is going to equal 2. So it's going to basically going to print 0, 0, 0, 0, 1. And then it's going to break up here, and it's going to exit and print a line. So it's only going to print 0 and 0 and 0 and 0 and 1, and then it's done. Here, it's going to start here. The label's inside that for loop, so then it's going to go to the y for loop, and it's going to go 0 and 0, 0 and 1. 2 will make it break up to here, but x is now 1. So then it's going to be 1 and 0, 1 and 1, 2 and 0, 2 and 1. 3 and 0, 3 and 1, 4 and 0, 4 and 1, and then exit. Okay, so this one will go through all the x values, while this one will only go through one iteration of the x values. Okay, so let's go ahead and cannot find symbol. What's going on here? Comma, not a semicolon. All right, let's do that again. Okay, cool. Cool. So we've done. So the first one, just like I said, it would only produce the values for x, where it's equal to 0. Now we got everything for all x values, but only y as 0 and 1. Cool. So placement matters. Placement can tell where the code is going to jump to. Okay. All right. Now. All right. Now I want to show you one last example with breaks. I want to show you. So this program is going to contain an error. It is not going to compile. Okay. Just a forewarning. I'm going to put a label, and then we're going to do a for loop. I'm going to say in I0, I is less than 3, I++, right? Let's make sure we adhere to our code formatting standards. Put some spaces in there. All right. So I want to print out the pass number. Okay, so pass 0. All right. And then this should print pass 0, pass 1, pass 2, pass 3. However, down here, I'm going to say, okay, int j equals 0. All right. J is less than 100. J++. All right. So now I want to say here, and this is where it's not going to work, right? J equals 10. We're going to say break to 1. Sure, you can already kind of see where this is going to fall apart, right? The reason why is we're gonna print pass 0, pass 1, pass 2. Then we're gonna fall out of this scope because 1 is associated with this block. It's gonna come down here. It's gonna start executing this for loop, and then it's gonna try to break on 1, but 1 is all the way up here, and it's out of scope. It doesn't know what that is. Okay, so let's go ahead and compile that. Come on. All right, let's clear the screen. Undefined label. Doesn't know what that is, right? Okay, so it has to be on the same level or internal on one of the lines that it's associated with, right? So if we had break to 1 in here, it would work. Just can't do it here. Okay? All right. Cool. Now, let's move on to the last thing we're going to talk about in this chapter before we get into awesome objects and functions and stuff. All right. I want to talk about the continue keyword. Okay? So, continue. What does that do? All right, let's go to the blackboard. Notice how I didn't talk about labels because I don't want you using them. So let's just say I have a for loop. I equals 0 with a condition, and then I++, right? And then I go ahead and I do some stuff, right? Okay, so I want to say like, if I equals 5, then I want to, come on, continue. Okay, so basically it skips any subsequent code and moves on to the next loop iteration. So if we had If we had this, more code would not happen when I equals 5. We can use continue to jump back up to this for loop and just basically short circuit any additional code. That can be very useful, okay? So in practice, looks something like this. So this is our use continue example. So we're gonna make an integer I, and we're gonna print only the even numbers between 0 and 100. Okay? So let's do I equals 0, I is less than or equal to 100, and then I plus plus. Alright, so I want to print, let's write our print statement. It basically just prints I, but we only want to print even numbers. Well, what is our handy dandy operator that we can use to ensure something is divisible by 2? Well, if it's divisible by 2, then that means when you divide it by 2, the remainder is 0. What mathematical operator can tell us the remainder? The answer is the modulus operator, if you remember that. This is where modulus operators are very handy. You can say I modded with 2. If I modded with 2 is not equal to 0, so if it's 1, right, then we're going to say continue. And just so we are being a little bit more clear here, I'm going to put it inside the scope body. And this iterates and skips over this. Okay? So let's try that, all right? There we go, 0, 2, 4, 6, 8, all the way down to 100 on the even numbers. Awesome. Cool. All right, so let's see. Now, I want to show you an example where we're going to use continue to a label. Okay? Whoops. Here's what I'm going to do. Okay. All right. So we're going to use continue with a label here. So let's go ahead and make our label called outer loop. Let's build our for loop, and we're going to have an integer I set equal to 1, and we're going to count all the way up to, well, less than 10, so 1 to 9. Okay, increment I. Cool. So we're going to print our outer loop message, and then we're going to also put our inner loop message on top of that so we can save some time here. So, we're going to print outer loop pass and then comma inner loop. Okay, cool. Let's put our inner loop, and it's going to be j is 1, same thing, j is less than 10, and then increment j. Cool. So normally we're going to print out j, so let's go ahead and print j. But here's our control statement, right? So if j equals 5, right, then we're going to say continue to outer loop. Continue to the outer loop label. Okay? I'm actually not sure what this is going to do, but I suspect that it might skip the rest of the for loop. I'm not certain. Let's find out. Let's try to distill this down. Test and measure, right? Okay, so
No sleep.
did pass 1 through 9. Yeah, okay. And then it only looped 4 times internally.
You don't remember
Yeah, so
what it was. Say it again.
this is effectively doing the same thing. Does the same thing as a break, right? It just goes back up to here and executes the next line of the for loop. So I equals 2, I equals 3. Yeah. Again, most things you can do without labels. Discontinue, you don't even need this. You get the same output, I believe, if you just... Oh yeah, it's just a break, right? Because if you had just continue here, then it would continue to the next iteration of this for loop, right? And it would actually process when j is 6. But because you did continue to this label, you're effectively using a break because you're breaking out of this for loop, discontinuing the processing, and going to the next iteration of this for loop. So this is the same as a break. See? It's I don't know. I don't like labels. All right. Cool. One more I want to show you. Oh no, not again. Fine. Okay. Okay. So this is gonna use nested loops
I say it again.
to find factors of numbers between 2 and 100. Okay? All right. Factors of numbers between 2 and 100. Okay, so basically we are...
No sleep.
Start with an outer loop. So I equals 2. And we're gonna go all the way from, space that. So all the way from 2 to 100. Okay. And then we're gonna increment it. Okay. Cool. So
And if the second time we didn't quite get it, I say it again.
So factors of I and, then we're going to have another loop, right? And we're gonna have J. And we're gonna start that one at 2. And let's increment that up. But let's figure out what that condition is gonna be. So
No sleep.
all right, we're gonna do J is less than I. And the reason for that is because that is going to target only half of the combinations, the half of the numerical combinations between 2 and 100. Because if we started to kind of like reverse these, and J started reaching 100, and then we were all the way doing the loop again for I is 2, we'd be duplicating our effort, right? So we're really just short-circuiting this, so we're only ever processing, in the grand scheme of both loops, only half as many combinations, like, or relevant combinations thereof. Cool. So let's print another line here, just an empty line. And then what I want to do is I want to say, okay, if factors of numbers do I mod 5, not I mod 5, sorry, I mod J, what am I doing? Getting tired. So basically, when we mod the two numbers together and the remainder is 0, they're a direct factor of each other. Okay? And then we can go ahead and we can print that out. That's a lot of lines. Let's not do a line here. Let's also not do a line here. Let's leave the line for here. I think that's killing the output. Factors of 102. Factors of 100. So 2, 4, 5, 10, 20, 25, 50. I have no idea what is going on. Because I have this outside here. I want this in here. I only want to print the number if it's a factor. I want to print this between every iteration. Okay, yeah. All right, let's run that again. Much better. There we go. All right. So factors of 4 is 2. Yep, so there are no factors of 5. Factors of 6, 2, and 3. 8 have factors of 2 and 4. So as you can see, it's printing all the numbers that are factors of those individual numbers. Okay? Now you can see how programming can be very useful for mathematical computations. Why a lot of analysis tools use that. For me particularly, I don't get into that side of things. I get into the more of the design and architecture, making programs do actual things. Yeah, this is some stuff that you can do. Okay, cool. So that's basically it. So that's today's lecture. Not very eventful. I do apologize for that. But I will say that we're going to get into some really interesting things next time. In the next chapter starts to get into objects, what they are. It's going to get into a loose idea of what pointers are, references and pointers, what methods are, methods on objects, how you can pass data into a function and get data out of a function, all kinds of cool stuff. And this is where the real special sauce starts to come into play. So, all right, so that's it. I'll see you on Monday. All right, see you later, guys.